going to solve a spiral order matrix question. Given a 2D array printed in spiral form, see the following example. Okay, it might be pretty hard to see, so I'm going to draw this out. And the output is 1, 2, 3, 4, 8, 12, 16, and 5 backwards, and like that. And stop here. The last element is 10. So the order to pop is, so first, so like if we can remove the whole line of elements. So first we need to remove the first line. Remove the first row, so it's row 0. That means we remove the top row. And then we go down, remove the right column, and then we remove the bottom row, and then we remove left row, left column, and after these 4 steps, we have the whole outside layer removed. And so for each time after we remove them, we should concatenate it to our result. For example, result is an empty array, then we should concatenate this remove the rows or columns. And then we should start again in the inner matrix. So we need to check if we still have some unused rows and columns. And to do that, we can mark like 4 marks. For example, here is top, and here is bottom, here is left, and here is right. And as we remove the a row or column, it will move like the. So first we did remove the top row, so top will become here, and then we remove the right column, so the right columns comes to here, and then we remove the bottom row, so bottom row come to here, and then we remove the left row, so the left row comes to here. So we will keep doing this until the right row and left row cross each other. For example, here becomes right and here becomes left. So that means it's not right anymore. We should stop. So yeah, this is approach. But to write a cleaner code, we can use a try and except. So we try to move a line of something, and then we try. So we try the first step, we try the second step, we try the third step, we try the fourth step, and if everything is successful, then we go back and try them again. If any of them is empty, then we will go to the except, and in the except we will just break the loop. The time complexity is O of m times n because we traversed the whole matrix, which is m by n. And the space complexity is O to 1 because we did everything in place with no extra structures. Okay, now let's write code in Python. So use M to stand for the matrix. Just result. So length of the matrix is bigger than 0. That means the matrix is not empty. Yeah, so if the matrix is empty, we should just return nothing, an empty list. So here it's not empty, so we're going to try to remove, try to pop out a whole row or list and concatenate it to the result. So the result this line will remove the top row. So to remove the right row, it moves a little bit more complex. So for x in matrix, x dot top -1. And to remove the bottom, so I'm writing matrix again. m. So 2m is just a 2D array, and for 2D array, if you pop from the 0 index, you pop the that means you just pop the first row, the whole first row. It just represents like the first element in a 1D array. So 2D array is just a 1D array, and each 1D array's element is itself an array. So when we pop the first element of this row, this 0, the whole row will get popped up. And okay, so for the same reason, we can put -1 here or not, because by default it popped from the end, so you don't need this pop. This is for the bottom row. Because we need to go backwards. So this is how we go backwards in Python. Reverse order. So for the left row, it's similar to the right row. We need to write it like this. So if any of this cannot be done, then we'll come to the except. So just break. That means we have nothing to pop, so we can break. And now we just return the result. Okay, that's it. Thank you for watching. Bye.